Hi, everyone, and welcome to reInvent. My name's Natalie White, and I'm an Enterprise Solutions Architect at AWS. And this session is DevOps 301, Testable Infrastructure, Integration Testing on AWS. Now, before I came to AWS, I was a Java developer for 15 years, and I don't care what your role is or how long you've been in tech, at some point this has happened to you. You make some changes. Today we're talking about infrastructure configuration. You do a quick code review on your own. You maybe have a teammate do a code review, run some unit tests, and maybe you even deploy your changes to a non-production environment just to make sure that the deployment is going to be successful. Everything looks good, so you deploy your changes to production. And maybe immediately you get reports that something has broken if it's related to connectivity or authentication, or maybe weeks or months down the road, you find out that a change that you made has affected some downstream process that was dependent on your infrastructure configuration, like a billing or reporting process. Either way, when you find out there's an issue, there's a mad dash to try and fix it as fast as possible and figure out what happened. Wait a minute. If you're an application developer like me, you had a mental record screech right there between the first and second images. What about integration testing? We've been using integration testing to verify the interaction between different layers of our applications and dependencies on other services and downstream processes for a long time. And there's no reason why integration testing can't also be a part of our infrastructure CI/CD process once we're doing infrastructure as code. We want to break this cycle of unintended consequences and build our confidence in the changes that we're making on a regular basis. Sound good? While we're talking about infrastructure and integration testing, it is always good to define what that means. And when we're defining what something means, sometimes it helps to define what it's not. Integration testing is not unit testing, right? It's not a static analysis of your configuration or your CloudFormation template if you're using CloudFormation. You want to programmatically verify the state of your infrastructure as a whole after it's been deployed. And running these sorts of tests can expose problems across whatever complex dependencies that your infrastructure has. And these dependencies aren't always obvious from looking at a single resource or a single CloudFormation template. It could be across services, across multiple applications, roles, and permissions. So running these sorts of tests can give you visibility into those dependencies and verify that you haven't broken anything. These tests can also expose downstream failures in a way that unit tests and eyeballing your changes can't. The changes that you're making could have a wider scope than just the functional requirements of your environment. Maybe multiple teams or multiple business processes are using what you're deploying, and maybe you want to verify that best practices and governance requirements are being met. And maybe these are things that are application specific that can't be verified by an organization-wide or an account-wide guardrail. Maybe some tagging. Another thing that integration testing can be used for is to expose any security gaps. So this can include revoking access that you didn't mean to revoke, or potentially more damaging, opening up access that you didn't intend to. So verifying your changes after they've been deployed can help find and visualize those security gaps without having to do any complex static analysis on your CloudFormation template. But the main thing that you want to take away is that you want to run these integration tests on an environment that is production-like as possible, because that repeated, consistent deployment methodology can reduce the risk of untested changes going into production. So now that we know what integration testing is, I'd like to talk about how you can use it not just on premises, but also obviously in AWS. Integration testing isn't unique to the cloud. And in fact, you can implement these same patterns that we're going to go through today on your on-premises infrastructure CI/CD processes But a few things are different when you're deploying infrastructure in the cloud, and so I want to go through those. So the first thing that's different about deploying infrastructure on premises versus AWS is that on premises, we get used to having stale and inconsistent environments. So if you're not already provisioning your infrastructure as code, you know the pain that's associated with having these stale environment configurations. And the most obvious example of this one that I have from my own experience is, say, a performance environment that hasn't been touched or used in several release cycles. You have to figure out when was it last updated, what changes have been made since then, what order do I need to apply those changes in, multiple support tickets, things like that. And deploying infrastructure as code kind of resolves all of those stale environments because you can deploy these changes programmatically and immediately across all of your different environments without having to submit a bunch of tickets and keep track of which ones are being applied. The second difference is that on premises, there's just no way to justify buying hardware or provisioning a production-like environment on premises for a system that's not going to be handling a production workload. In fact, sometimes a single server is running every layer of your application, and sometimes it's running multiple applications, right? You can't have a production-like system on premises because of the financial impact. But when you're using infrastructure as code, and deploying into the cloud, you can provision a test environment just to run those integration tests and then destroy it when you don't need it anymore and you've only paid for the few minutes that those tests have run. And the third and most important difference is the culture change that comes along with moving into the cloud. On premises, we have gotten really used to having functional silos for our development and release processes. The IT team manages infrastructure. The application developer tosses artifacts over the fence to deploy on that infrastructure. The database team only does databases. The security team can really only look at static reports from code analysis or running periodic pen tests against production. And no one on the technical side has any idea what anything costs because the hardware in the data center is already a sunk cost. But the only thing we did know is that there were never enough servers to do what we wanted in non-prod systems. And so then when issues occurred, it's always a struggle to determine who has the responsibility to determine a root cause and who has the authority to fix it. But when you're deploying things into the cloud and using infrastructure as code, those silos are flattened and teams own everything that they build. The IT team can automate the heavy lifting of what they were doing before and focus more on strategic initiatives. Application developers can provision infrastructure on their own without having to wait for another team's availability. And you can migrate fully managed database services and focus on the business value of the data itself and how your application interacts with it. Security teams can now get full visibility into the entire system and implement guardrails and remediations to prevent breaches ahead of time. And what each implementation costs is transparent to the teams that have ownership over their own cost optimization. So it's a paradigm shift for many of our customers, but it creates the autonomy and efficiency that allows your teams to use the skills that they already have to do more than they could before. But with that ownership comes a lot of responsibility to put processes like integration testing in place to guard against the kind of production issues that we're talking about. All right, now we've talked about what integration testing is, why it's important, and who's responsible. So I have 3 patterns that I want to go through to show you how you can start implementing integration tests in your own CI/CD process. And they're in order of complexity, so they kind of build on each other. Pattern 1 is the simplest. We can start invoking Lambdas from our code pipeline. This is a 300 level talk, so I'm already assuming that you know about CI/CD processes and our code suite of developer tools. If you haven't, go check them out. They're awesome, and they're what I use to build these demos in my presentation. So we have our pipeline, we have a code repository, we have a build that happens, and what we want to do is deploy the same CloudFormation stack in multiple environments and have tests running in between to verify and guard against breaking changes going into production. So You'll notice that my test environment and my production environment, I intentionally left blank. It doesn't matter what you're provisioning or what you're deploying. It could be a single S3 bucket. It could be a multi-tier web app. It could be a Fargate cluster. It doesn't matter. All that matters is that your tests are running against that test environment and able to assess the status of that infrastructure after it's been deployed. You'll also notice I have 3 Lambdas here, and they're kind of floating out in the middle of nowhere because pattern 1 assumes that you've already deployed these Lambdas in either a manual way or a separate pipeline, and they're just sitting out there waiting to be invoked when we run our deployment pipeline. I've divided them up into subject domains, so I have a set of default tests that could maybe look at governance requirements. I have a networking test suite that will test a networking configuration. I have a security test suite that will look at my security configuration. And you can divide up your tests the way that you want, but you do want to find a balance between having a single test running in a Lambda, because then you have a lot of Lambdas, and it's not very efficient because you have to wait for those to be invoked. And the other side of the spectrum is you have all of your tests running in a single Lambda, which isn't very efficient because you have to wait for them to all run sequentially, and because you don't have a lot of visibility into where you're at during the test run and what happened. So as a part of our pipeline, we're going to create some Lambda invocation actions, or you could create a custom resource, whatever you prefer, to go into and execute those Lambdas, which will run tests against the test environment, and assuming everything is good, then you'll deploy your changes to production. So I'm not going to demo this pattern because it's really just a place for you to get started testing out integration testing in your own infrastructure. We're going to iterate on that for pattern 2 because there are a couple drawbacks to this framework. The advantages of it is that it's simple and the test scope is readily apparent from your pipeline. You can see which tests are being run, in what order, and they're all failing independently. But the Lambdas are provisioned outside of the pipeline, which means that our tests are hanging out somewhere else, not in our infrastructure repository, and there's a separate process that you have to keep track of to make sure that everything is in sync when you run the pipeline, so you don't have issues being reported when they're not issues and you're running the latest set of tests. The other drawback is that potentially, if you continue with this pattern into the future and you keep adding Lambdas and adding tests, you could eventually hit CodePipeline action limits, or if you're using custom resources and custom actions, there are limits there as well. So if you continue with this pattern, you may run into those limits, and there are other ways to execute your tests and orchestrate them that provide you a little bit more flexibility. Like I said, pattern 2 is going to build on pattern 1. We have the same pipeline and the same deployments happening, but this time, instead of having the Lambdas sitting out there waiting to be invoked, we're going to use CloudFormation to deploy them as a part of our pipeline. So those Lambdas will be in our code repository right along with all of our code that's making our infrastructure changes. And we'll have the same Lambda actions as a part of our pipeline to deploy or to execute those Lambdas, which will execute the tests and then go to production, assuming everything is good. Now, I do have a demo to show you how this is going to work. So we'll get into that now. Now, I built my demo using CDK for TypeScript, which builds my CloudFormation templates. And you can see 3 templates, 3 stacks that have been deployed here. My demo stack just contains the pipeline that I just showed you. It's a convenience for me to deploy it as a CloudFormation template. And we're not going to dive deep into that because it doesn't matter how you build your pipeline, really. You can also see that there is a test environment stack and a prod environment stack, just like we saw in the architecture diagram. And for my demo, all that's being deployed into these is a single S3 bucket and a VPC. There are 2 instances of the same template that are using a property to rename them depending on which environment I'm deploying to. So you can see the resources that I'm deploying here, again, are my S3 bucket and a VPC that's just using the default configuration. So it has all of the subnets and everything that comes with a default VPC. And you can see that my production environment stack is deploying the exact same resources, renamed so that we can easily differentiate them. All right, so that's what's being deployed. I have one more CloudFormation stack that's being deployed, and that's for my Lambda tests. So we'll go take a look at that one. So this is deploying all 3 of my Lambda tests and all of the roles that they need to be able to run their tests. But the main thing I want you to take away from this is that as a part of my deployment, I'm publishing those Lambdas deployed ARNs, so I can pass those along in the code pipeline for my execution stages. All right, now we can actually look at those functions. You can see I have my 3 functions here that are being deployed, and there's an additional Lambda there that's going to be my invocation action as a part of my pipeline. We don't really need to look at that because all it's doing is invoking my Lambdas, but my tests actually have all of the same code within them, so we'll explore them just by looking at the defaults stack for now. You can see here I'm using a Python testing framework. You can use whatever framework you're familiar with. If you're a PowerShell person, you can use Pester. If you don't want to use a framework at all, you don't have to. This was just for ease of demo and reporting and things like that. And we can look into our code and see what tests are actually being run as a part of each of our test suites. Each of them is using this same framework of going and getting my deployed CloudFormation stack and using the Boto3 resource API to get the deployed resources. And then we can use those resources to assert that certain things are true about them. So the test that I'm running here, I'm going to go make sure that my S3 bucket has some kind of tagging going on, and it will anyway because it's being deployed by CloudFormation. But I also want to verify that my default tag that I've put there is one of the tags, because maybe I'm using that for a billing process or a reporting process downstream. This could be something that's not needed for the functionality of an application running on this infrastructure, but it might be needed for a downstream process. Then I'm testing and making sure that my S3 bucket is versioned. Again, my application may not even need that, but for auditing purposes, maybe it does. So your test can really be anything here. This is just an example of what you can do with that resource API and verifying the deployed infrastructure. We'll move on to my networking test. It just goes and looks at my VPC and it makes sure that the VPC exists, that I have a CIDR block that's actually the default CIDR block. I didn't intentionally set that. And then it's going to make sure that all of my VPC subnets are available. Again, these tests can really be anything. It's up to you. My security test, I just have one test in there, and it's for the S3 bucket, and I'm verifying that it doesn't have any ACL access configured. Actually, my bucket is blocking all private access, but this is one of those preventative tests that you could put in place to make sure that no one makes changes in the future that might cause a security issue. All right, that's it for Lambda code. Now we can go look at my pipeline. It looks exactly like my architecture diagram. I have a source stage, a build stage, a deployment stage, and a test stage. And then, of course, after that, we deploy to production. Of course, this has already been a successful run, but what we want to do for the demo is make some breaking changes and see what happens. So this is CDK TypeScript code, and it's how my environment stack is being built. And you can see that my multi-stack property there is determining whether this is a production environment or a test environment. And it's changing the name of my bucket and my VPC depending on the value of that property. I'm deploying my S3 bucket with all of the configuration that goes along with it and my default VPC as a part of the CDK framework. I'm going to comment out that my bucket is going to be versioned, which will change the status to suspended. And I'm going to remove that tag because as an application developer or an infrastructure developer, I don't think I really need it. So we'll promote those changes, push those changes into the code repository, and see what happens. All right. So you can see that my source has now been updated. My breaking changes have been recognized and my pipeline has started. And these pipelines actually take around 6 or 7 minutes to complete, but I've sped up the video just for your own sake watching it. Now we've built. We're going to deploy our CloudFormation templates that were built as a part of the build step using CDK Synth. And now we can invoke the test that we just deployed against the environment that we deployed. Okay, so we can see that our default test failed, and I'm returning the details of those failures back from my Lambda so that you can see from the pipeline what failed. My networking and security tests were fine, so those succeeded, but because my default test failed, I didn't deploy anything to production. All right. So as you can see, adding integration tests to an existing pipeline is pretty easy by using Lambda tests. And we've resolved the issue of our tests not being up to date and our tests not being close to our code because they're part of our same repository and they're being deployed as a part of the same pipeline. However, this approach still has some drawbacks. Using Lambdas invoked directly from CodePipeline can be a very brittle way to run your tests. If you have a bunch of test suites that are running in a combination of in parallel and in a series, if one Lambda breaks early on in the process, the rest of them aren't going to run at all because the pipeline is going to stop right there. You have very limited workflows. You can only choose whether they're going to run in parallel or series. You can't add any conditional statements or anything like that. Your pipeline is just going to run and it's going to fail at the first failure. And you don't have any option to retry until you make some changes. Well, we can iterate on this pattern for a third time and add AWS Step Functions. So this pipeline is exactly the same as my first two patterns. And instead of deploying Lambdas, we're going to deploy the Lambdas along with a step function state machine that's going to define how those Lambdas are going to be run and define a more conditional workflow that we can use to create a more dynamic test run. We'll still use a CodePipeline action to invoke that step functions state machine. And as we do that, the start state will go into, in this case, I've coded mine to still run in parallel like they were in the previous pipeline. They'll run tests against the test environment, and then they'll consolidate their output and return that back to the pipeline and then on to production if everything's okay. The demo for this one is much shorter because we don't have to go through all of the buildup of what's happening in the pipeline and what's being deployed. I have the same framework that I had in pattern 2. In pattern 3, we have my demo stack, which has my actual pipeline in it. And we have the same test and production environment stacks being deployed. They have the same exact resources in them. Nothing has changed, so we won't spend any time looking into those. My pipeline also looks exactly like my architecture diagram. I'm deploying my step functions workflow, and then I'm executing it in the next step. And my Lambdas also look very similar. The same tests are being run, but now, and we still have a test proxy, which is actually going to be invoking my state machine instead of my 3 Lambdas. And then we have an additional Lambda here that's going to consolidate all of the test results from those 3 steps being run in parallel and return those back to the pipeline. The nice thing about step functions is you can get a historical view of previous runs and you can view those results graphically. So we'll go look at a previous successful run to see what's actually happening. You can see I have my start state. I'm going to run all 3 of my tests in parallel. I'm going to consolidate the results, and then I'm going to determine whether any tests failed from those results. In this case, everything passed, so we're good. But now that means we get to go make some breaking changes and see what happens. You can look at the trace of where steps were entered and exited. You get a lot of really great visibility inside of step functions. So we'll make the same breaking changes as before. We'll remove versioning and we'll remove our tag. And we're also going to make a change to the security test so that we can see how those test results are consolidated. So I have this commented out test, and I'm going to uncomment it so it runs. And I'm still doing my ACL access test, but now I'm making sure that there are no public subnets inside of my VPC. So we'll uncomment that test. What it's actually doing is it's going and grabbing the route table that's deployed as a part of my VPC, and it's looking for an internet gateway. And if that internet gateway has any subnet associations, I'm going to report that there's a public subnet in this VPC. So we'll push those changes to our pattern 3 Git repository, which will trigger our code pipeline. Our source changes were picked up, so we'll move on to the build process. The build process is running the same TypeScript tests and CDK synth to generate my CloudFormation templates. We're deploying that test environment and my Step Functions CloudFormation template. And now we're running our state machine. All right, it failed. So because I'm consolidating all of the test results, I can see them all here in my pipeline, what failed. And if I want additional visibility into what failed and why, I can go into Step Functions and go look at that most recent invocation and view what happened. So you'll see there weren't any issues actually running my tests, so you can see that all of those were successful. However, the output that they're providing is showing that there were some issues with the tests that were run inside of them. We consolidate those results, so we're combining the results from the default test and the security test into a single list of things that went wrong. And then we're using that conditional did any test fail to determine what state our state machine will end in. All right. So this keeps the same advantages as pattern 2. Our tests are always being updated, they're close to our code, but it adds a couple more advantages over the Lambda only integration tests. The consolidated test results can be propagated to dashboards or email reports or a persistent data store for immediate visibility into all of the tests that failed. You can use all of those service integrations with Step Functions to configure notifications or remediation actions depending on how severe those issues are. And Step Functions allow you to orchestrate the tests in not just parallel or in series. You can have conditional flows, like say, if this test fails, I don't want to run all these other tests. Or maybe I want to run the same state machine against a development environment and my integration test environment, and maybe even against production, and only run a subset of tests against each environment so that I can speed up my build time. You can configure error handling and retries as a part of Step Functions. And if you create the pipeline itself within CloudFormation, with or without the CDK, it's a pattern that can be used as a starting point for new projects and shared across teams. So you can start propagating these best practices of running integration tests as a part of your infrastructure deployments into the future. So we walked through 3 different patterns that you can use to get started, adding integration tests to your CI/CD pipelines. And hopefully these gave you some ideas of how you can start to do this and build on those ideas moving into the future. Thanks a lot for listening to my talk. And if you found it interesting and enjoyed it, there is a similar talk or a related talk in the Builders Library suite of sessions, and it's called Testing Software and Systems at Amazon, from Charlie Roberts, who's a senior software developer and test here at AWS. And don't forget to complete your session survey. It really helps us to improve content going forward. Let me know how I did, and thanks for watching my session.